Thank you for joining us again. Just to give you a heads up, in this video we're going to go through some of the theory that we've used in the first two example videos for this module on trigonometric identities, and my intention is to try and explain where some of the formulas have come from that we've used in our first two example videos. So firstly, we're going to use the sine of two angles, t plus alpha. And this is one of the formula that we've seen in the module, is equal to the cos of alpha times sine of t plus the sine of alpha times cos of t. So one way to remember, a useful way to remember these formula is that sine of two angles, sine has the same sign, so if it's plus here, it's plus out here, but it's got different functions. So that's a useful way to remember the double angle formula. And by the same token, cos of t plus alpha, this is cos of t, cos of alpha, minus sine of t, sine of alpha. So a good way to remember this is that cos is the same function but different signs. In this video though, we're just going to concentrate on the sum of two angles for a sine function. So here, as we've seen, we're interested in writing something times sine plus something else times cos as a single sine function. So if these numbers are larger than 1, we're in a bit of trouble because cos alpha and sine alpha can't be larger than 1. So one way of dealing with this is to multiply this equation through by a, or an amplitude. So what we're saying here is that this thing here, t is our variable, cos is a constant. We want this thing here to agree with the thing in front of the sine, and we want this whole thing here to agree with the thing in front of the cos. And what we're essentially doing is we want to work backwards. We want to write these two things as a single a sine t plus alpha. And as we've said before, this is very useful because this can be cumbersome to deal with, and this can be a whole lot simpler to sketch or to use to solve problems, to solve algebraic or numerical problems. So the question is, how do we find a, the amplitude of this sine function, and how do we find alpha, the horizontal shift of this sine function? We know that, so from up here, we know that a cos alpha is equal to the thing in front of the sine. We also know that a sine alpha is equal to the thing in front of the cos. And we need to try and use these two equations to find both a and alpha. One way of doing this is to divide this equation through by a. So this gives us that cos alpha is the thing in front of the sine divided by the amplitude, and sine alpha is the thing in front of the cos divided by the amplitude. And we can use one of the other trigonometric identities, and that is that cos squared alpha plus sine squared alpha is equal to 1. Substituting this in for cos, we get a little a on big A squared. Substituting this in for sine, we get little b on big A squared is equal to 1, or a squared on a squared, the amplitude squared, plus b squared on the amplitude squared is equal to 1, or multiplying through by a squared, we get a squared plus b squared is equal to the amplitude squared. So this tells us that if we want to find the amplitude of our new function, a is just the square root of the thing in front of the sine squared plus the thing in front of the cos squared. That's how we find our new amplitude. To find our alpha, the horizontal shift, we can use these two functions. Cos alpha is the thing in front of the sine divided by the amplitude. Sine alpha is the thing in front of the cos divided by the amplitude. And as we've said in our example videos, the important thing to do is look at the sines, the SIGN of both of these. And as we've said, we're going to use the sines, or we have used the sines, to find out what quadrant alpha is in. If both of them are positive, it's going to be in the first quadrant. If sine's positive only, it's in the second quadrant. Sorry, that's tan, and that's cos. So if, for example, cos is positive and sine is negative, we can tell that the angle must be in the third quadrant. So as I've stressed, as we've said all along, it's important to look at the sines of sine and cos to determine what quadrant alpha is in. And let's just keep in mind what we're doing is we're trying to look at this expression and we're writing it as a single expression. And as we've seen, there's lots of advantages to those. Thank you.